Good morning, everyone. Just wanted to take a minute to talk a little bit about the Pythagorean Theorem and its converse. That'll be very useful for us when we are categorizing triangles. So, what are our goals for the day? Well, our goals for the day, oh, thank you, are determine the lengths of triangles using Pythagorean Theorem, specifically usually like the hypotenuse for some of the legs, and then to classify triangles based on the converse or the derivations from the converse of the Pythagorean theorem. All right, and by classify, I mean we're going to talk about acute, right, and obtuse. Forgot which one I said first. So some vocab to make sure we're on the same page. You've probably heard all of these before, but just to be certain, the hypotenuse, that is the longest side of the right triangle. It is opposite the right angle, right? Draw a line across, we hit the hypotenuse. It'll be the longest. That is because based on what we remember from the triangle inequality, right? Longest side, opposite largest angle. If it has a 90-degree angle, that has to be the largest angle because I only add up to 180. So this is the hypotenuse. Usually you denote it with C. And then you have the two legs, which are the two other sides, the two shorter sides. You typically call them A and B. They're really kind of interchangeable which one you feel like calling A and B, but they are called A and B. So, the Pythagorean theorem. You know it, you love it, you've used it. Let's go over it. The Pythagorean theorem is just a theorem that states if you have a right triangle, okay? I'm going to write this down. So, if right triangle, then a squared plus b squared equals c squared, right? You've seen this before. The formal way of saying it is if you have a right triangle, then the length of the hypotenuse is equal to the sum of the legs squared, or the sum of the squared legs. So there's all kinds of different proofs on it. You can see the one with the squares. That one's a nice visual one. You could look at, there's one with making a bigger square. There's an interesting one, I believe, with, I think it's a trapezoid. But anyway, there's a lot of different ones that you could look at and solve. All right, so how do we actually do anything with this? Well, simple enough. A squared plus b squared equals c squared. So this side is equal to, if you undo the square, right, you do a square root. That's why they could just write it like this. Square root of ab squared plus bc squared equal to ac. Take the square root, you end up with 5. This is a very common one. If you see a 3 and a 4, you can just write a 5. So let's actually use this. So the missing side, we need to find it. So we need this. So we have that a squared plus b squared equals c squared. We still need to figure out what c is. We don't know what it is, but we know that a and b are going to be 7 and 8. It doesn't matter which order you put them in. Addition's commutative, so it doesn't matter. 7 squared plus 8 squared is equal to c squared. So that would be 49 plus 64 equal to c squared. That makes my c squared equal to 113. So c, don't forget to take your square root, is the square root of 113. Now, based on what we just looked at, let's talk about simplifying radicals. So this is going to be a good one for me to check by dividing, right? So let me divide it by 4. Is that going to work? No. You can probably guess that's not going to work. It ends in a 3. If something ends in a 3, it's not going to work for 4. Let's divide it by 9. Nope. Well, 4 didn't work, so 16 is not going to work. Right? Yeah, still doesn't work. So let's try 25. Well, you can tell that's not going to work. Let's try 36. I don't believe that's going to work either, and it doesn't. Now we're at 49. Nope. And anything after 49 is going to be bigger than half, so we're done. We cannot simplify. It is the square root of 13. All right, so that is my final answer. Okay. Now, this one over here, we know that, again, a squared plus b squared equals c squared. So we have that 9 squared plus b squared, because we don't know b, is equal to 12 squared, right? So I have 81 plus b squared is equal to 144. 144 minus 81, so that would make me equal to b squared. What is that going to be? 63? Yes, 63. Yes, just confirmed it. So b is equal to the square root of 63. Now, again, we are going to see if we can simplify the radical. 63 is divisible by 9, right? It is the square root of, well, 9 times the square root of 7. Can't do anything with the 7, but I can work with the 9. So there's 3 square roots of 7. If you can simplify, you should simplify. That is the general rule. It makes things a little bit easier to deal with. All right. In general, you'll get something with like a 3 or a 2 or 4 out front. Every once in a while, you get something crazy. But you never know. All right. So let's move on. Quick little shortcut. If you come across something that is known as a Pythagorean triple, you can get away without doing much. So a Pythagorean triple consists of 3 positive integers, a, b, and c, such that a squared plus b squared equals c squared. So basically what it's saying is these ones and their multiples are just nice versions of numbers that you can find. So if you see a 3, a 4, you know the last one's going to be a 5. Same thing with the multiple, by the way. So 6, 8, 10 will also work. 9, 12, 15, also going to work. Okay? So if you ever see any of these, you could just write them down. Most people don't really remember more than these first 2, to be perfectly honest. I don't know if I remember that one. But these 2, you could probably remember, and it might save you some time. All right. Now, let's move on to classifying triangles. So this kind of comes from the converse of the Pythagorean theorem. Really what we're saying is, before we knew we had a right triangle, and we said because it's a right triangle, we have a squared plus b squared equals c squared. Now what we're saying is, we don't know if it's a right triangle, but if I plugged it into the Pythagorean theorem, let's see what happens. So, if you plug it into the Pythagorean theorem, and it works, then you're going to get that it's a right triangle, okay? That's all the converse is saying. All right, so if you plug it in, you find that a squared plus b squared is equal to c squared, well, that's a right triangle. If you find that c squared ends up being less than a squared plus b squared, it'll be acute. Okay, so what do I mean by that? I mean, let's say c squared was, 49, whatever, and that a squared was 36 and b squared was 25, right? That's going to end up being acute, right? Because 49 is less than 61, okay? So that would be acute if your c squared is shorter than your combined other 2. Now, the obtuse triangle is going to be if your c squared is larger than a squared plus b squared. And where would that end up coming in? That would be something like if, right, this was like 100 and this side over here ended up being like 70 or something. Okay, so on this one, smaller one would be c squared. Up here, larger one, c squared. All right, so let's look at an example or 2 examples. So 2 examples here. For classifying them as a right, obtuse, or acute, what you're going to do is you're going to figure out the a squared plus b squared and c squared. You ultimately get that 61 is less than 64, which is your c squared. So it is obtuse, right? If c squared is the biggest number, it's obtuse. Well, okay, let me rephrase that. If c squared will be the biggest number out of the 3, right? So a squared is definitely going to be, smaller than c squared. B squared is definitely going to be smaller than c squared. C squared has to be the longest side. But what we're saying is if c squared is larger than the other 2 added together, then it's obtuse. Over here, we find that c squared is, 15. C squared is 225 because it's 15 squared. And over here, we find that a squared plus b squared is bigger, right? C squared itself is bigger than 81. C squared itself is bigger than 169. But it's not bigger than them both added together. So this ends up being a cube. Okay? So let's do this. All right, so let's just look at this. We would need, let's do this. So we have 3 squared plus 4 squared. And then here we have 5 squared. Okay, so I'm going to leave this blank because I don't know what the symbol should be yet. So this would be 9 plus 16. This is a Pythagorean triple. You probably already know the answer. So 25 is equal to 25. So this is right. All right, this one over here. We end up with 3 squared plus 4 squared, and then we have 6 squared. I'm going to leave this part blank. So 9 plus 16, 36, 25, 36. So this part is bigger over here. That makes c squared larger than both of my other ones, so therefore this is obtuse. All right, and then the last one's over here. I have 3 squared plus 3 squared, and then I have 4 squared. So I have 9 plus 9, 16. 18 is bigger than 16. That means a squared plus b squared is bigger than c squared, which makes this a cube. All right, and that's all there is to it. Pretty much all you're going to do is you're going to figure out a squared, b squared, c squared, and then figure out where to put the inequality. If a squared plus b squared is bigger than c squared, it is a cube. If a squared plus b squared is less than c squared, it is obtuse. And finally, if they are equal, it is a right triangle. All right. So hopefully that shouldn't be anything too crazy. And let me know if you have any questions. Have a great day.